Okay, conversations are dying down, so help me out. Mason, what's something your group talked about for transformations?
A determines if it's a stretch or shrink.
Okay, yeah. This A is stretch or shrink. Now, we did have like two issues with A, like was A outside, so it was affecting Y, so it was vertical stretch or shrink, or is it inside right in front of the X, so it's a horizontal stretch or shrink. I'm pretty certain, like with exponentials and logs, that we basically would keep A on the outside, so it would really be responsible for vertical stretches and shrinks. Although I am also at the same time thinking that I don't really give you any stretches or shrinks. So they're going to be like basic, but not stretch or shrink. So that might, I don't have any of my examples. I don't think there's any on the homework. So think about that. Okay. Great. Colin, what's something else you and your group talked about?
Like H moves like up and down.
Did you say?
H moves like a graph up and down.
Did we agree with that? No, H actually moves the graph left and right. That's okay, it's been a while. Someone up here was talking about this is the very first thing we did, right? And that's because, you know, like thinking about what is the difference between H and K, H is the one that's usually like in the parentheses with X, right? So like it's in the absolute value, or it's in the parentheses that's being squared, or it's under the square root, all those different things. And so that means that it's affecting X because it's with the X, so it's moving the graph horizontally, which would be left and right. Which then leaves K to be our up and down, okay, shifting, excellent. Do you remember any other transformation that we can apply to graphs? Yes, someone said, a few people said reflection, and that is a negative A. Now, again, where A would determine what type of reflection you have. You could have a reflection in the x-axis, so it flips down. You could have a reflection in the y-axis, so it flips over. Generally, I'm going to keep A on the outside, so that would be a flip down, right? Okay, what else is something else we used to always talk about with A, H, and K that you have to be really careful of? Anybody remember my warning about A, H, or K? What was the opposite, or looks like the opposite? The horizontal stretch or shrink does, yes, that would be a good one. But remember, I'm not really going to give you horizontal stretch or shrink, so we're going to kind of like pass over that one. No. H looks like the opposite in the equation. Okay, so maybe make a little note to yourself. H looks like the opposite of what it really is. And the reason why H looks like the opposite of what it really is goes back to how the general form of the equation looks. And I'm going to do one for exponential and one for logarithmic. So an exponential general form could be something like this. Y equals A times B to the x minus h plus k. So remember, way back in section 6.1, I only had you graph b to the x. Now we're going to see the different transformations being applied.
Wait, so A and B multiply,
Yes.
and then you do the exponent?
No, you would do the exponent first. PEMDAS, parentheses, exponents, multiplication. Okay, so now notice, why does h look like the opposite? Because in the equation, it's x minus h. So if I put in a positive 3, it looks like x minus 3. If I put in a negative 3 for h, it looks like x plus 3. But k has a plus sign in front of it, so it actually looks like what it is. If you saw like a negative out in front, remember we talked about b has to be a positive number that is not 0 or 1. It can't be negative. If you saw a negative out front in an exponential function, then that must be your a value, so it would be a reflection. Here's your log equation. Y equals a times the log base b of x minus h plus k. So again, to kind of reiterate that point of the difference between h and k, notice h is always paired up with x in these equations, so it's affecting our graph horizontally, which would be shifting it left or right. K is always like added on the back of it, so it's really affecting the y value. Okay, it's like you've calculated y and then add k to it, so it's moving your graph up or down. Okay, so let's put this to work. What's this going to look like for you on your homework, on your quiz, on your test, going forwards? I've got two equations. F of x equals 3 to the x. G of x equals 3 to the x minus 4 plus 2. Okay, I think on the homework and on the quiz, I probably ask you, I like give you these two equations. I'm always going to give you the simple one. And I'm going to ask, like, describe the transformations from the parent graph. So you're going to look for, is there an a value in this problem? No. Is there an h value? Yes. Since it says x minus 4, h is actually, just, remember it would be x minus h, so h is 4, which means my graph is moving right 4. So my transformation is right 4, and then this value in the back is k, which is responsible for up and down, so it's going up 2. So what we're going to do is we're going to take the basic graph that we already practiced graphing. This is real easy. What 3 numbers do we put in for x? -1, 0, 1. What do you get out for y? 1/3, 1, 3. And I'm going to plot these 3 points. -1, 1/3, 0, 1, 1, 3. This is the original graph, right? The f of x. So I'm going to make it dotted. What do I want to do to that graph? Transform it. Move all the points right 4 and up 2. So I'll take this point, which is -1, 1/3, and I'm going to go right 4. 1, 2, 3, 4. And then I'm going to go up 2. 1, 2, so I'm at 2 1/3. Make a point. Go to this point at 0, 1, right 4. 1, 2, 3, 4. And then up 2, so I'm at 3. And then I'm going to take this point, what is that, 1, 3. I'm going to go right 4. 1, 2, 3, 4. And then I'm going to go up 3. 1, 2, 3. So I'm at, what, 4, 6? What else moves besides my points? What line? the asymptote. The asymptote on my original graph is here on the x-axis. What transformation will really affect my asymptote?
Down to down.
Right or up? Up is going to affect something that's horizontal, right? If I move this left or right, do you notice? No. But if I move it up 2, you notice. So now my asymptote is at y equals 2. And then I can draw my real function. Okay. Now, in the later examples, I'm not going to like draw the dotted one. I'm just going to like put those points down and move them. And then I'll just draw it one time. But most important, maybe make a note to yourself here in the notes is you've got to transform the asymptote too. That helps you get the correct graph. A lot of people who don't draw the asymptote right away, they're going to draw the old version that comes down to the x-axis. So you need to be aware that your asymptote is potentially going to move with one of the transformations. All right, what would you say for domain? X equals all real numbers. What would you say for range? Y's greater than 2, because we're now have to be above that asymptote line. To say greater than 0 would imply that there's something in between 0 and 2, and there is not. And then my asymptote is y equals 2. Okay. Let's do another one. Does anybody have any questions on that before I move on? Okay. We'll do f of x equals 1/2 x. G of x equals negative 1/2 x minus 5. First, name your transformations. Tell your group members what transformations you see in that equation for G. I would say reflect, go down. Your asymptote should be going down. If you were to go down and then reflect, then your asymptote would go up. You should reflect and then move down. Okay, so I heard reflection in the x-axis right away, and then there was like maybe some like discussion. Is it gonna be like right 5, left 5, down 5? Right? Those are the questions. And what did we decide? Down 5. Okay, I agree. Now, there is also the question about like what order you should do those. And to get the appropriate graph, what you would want to do is think about what if I reflect my points? So reflect them over the x-axis and then move them down 5. In the end, you should see always your asymptote should agree, like for exponential functions, with the horizontal or the vertical shifting. So if your graph is going down 5, your asymptote should be down 5. Okay, let's make a table of values for x and 1/2 to the x. I'm going to put in negative 1, 0, and 1. That's going to give me 2, 1, and 1/2. And I'm going to plot those points, negative 1, 2, 0, 1, 1, 1/2. And then I'm going to reflect and shift. So if this is at 1, positive 2, when I reflect it, it will be at 1, negative 2. Okay. And then I'm going to go down 1, 2, 3, 4, 5. Looks like I ran out of tick marks. Yeah, it looks like -7. What's that? Mason, did you have a question?
No.
Okay. So reflect first and then count down 5. So now I'm at the second point, which is at 0, 1. Reflect it so it's at 0, -1, and then go down 5. 1, 2, 3, 4, 5. And then do this one, 1, 1/2. Reflect it, go down 5. 1, 2, 3, 4, 5. I think my graph is pretty off. I apologize.
Would it be
I
negative?
My this point I'm gonna move in. This point is way too far out there.
Is there an undo button?
What the heck? That was strange. I've never seen that big. I've seen it, the big circle, but I've never seen that big. That was crazy.
Probably have to change.
Okay, that's right. I need to change my graph anyway. What's this one at? -6? And this one should be like right here. Yeah, that looks a little bit better. Okay. What else will shift? The asymptote. And the asymptote would have been at the
Wow, it's X.
x-axis. So now we got to move it down 5. So 1, 2, 3, 4, 5. My graph is pretty good. Sorry. There's my asymptote, which means my graph must look something like this. Okay. Domain?
Less than 5. Oh wait, no, sorry. All real numbers.
All real numbers. Range? Wise? Less than -5. Asymptote? Y equals -5. You should always have like a matching range and asymptote value, right? Is this growth or decay?
Okay.
This is decay
Because it's 1/2.
because the base was 1/2. Some people may be tempted to say growth because the graph is increasing. But remember, it's not about increasing or decreasing. It's about how fast that is happening. It's about your rate of change. So this graph is increasing fast on the left, but then all of a sudden it slows down. And as we approach the asymptote, it's like we're not even increasing at all, right? So it's very, very slow. Okay. Any other questions about that one? All right, let's do a log. So go ahead and jot this down. If you need to go to the restroom or anything, you are welcome. Okay. We're going to do log. Same idea, just a different shaped graph. So we'll do f of x is going to be log x. And g of x is log of x plus 4 minus 3. Okay. So I'm going to make a table of values for x and log x. Do you guys have a preference? I know I did that example with Abby. Like, do you want to do the b inputs or do you want to do the y inputs, -1, 0, 1? Does anybody have a preference there? The b's, I heard? Okay, then I'll do b's. Okay, what is the base for this log? 10. So I'm going to put in 10, b. I'm also going to put in 1/10, 1 over b. And I'm also always going to put in 1. Because when you do the log of anything, log base anything of 1, the answer is always 0. Because you're asking what exponent do I need for that base to get to 1? And the answer is always 0. So this one's going to be -1, this is 0, and this is 1. What transformations are happening to your graph? Left 4, and down 3. this. I gotta go left 4, and then I gotta go down 3. I think that should get me about where I need. Okay, so I'm going to plot the original points, just the points on this one. 1/10 -1, so that's about right here. 1, 0, and 10, 1. It's far out there, right? Where is your asymptote for this log? The y-axis. Remember, logs always have vertical asymptotes, so just kind of keep in mind, like, if you were going to draw this, you would draw it, like, slowly rising over to the right, but on the left it would come down at the y-axis, right? So now I got to move everything left 4 and down 3. So I'm going to take this point right here. I'm going to go left 4 and down 3. Same thing here, left 4. Having a hard time counting. And down 3. And then left 4. And down 3. Should be a 1. Which of those transformations is going to affect my vertical asymptote? The left 4. If your vertical asymptote is here at the y-axis, it's going 1, 2, 3, 4 to the left. Again, my points are probably. That's scary. Points are probably not that great. 1, 2, 3, 4. Yeah, I went too close. 1, 2, 3.
That was hard to grab.
1, 2, 3, 4. 1, 2, 3. Okay, that's better. A little bit. Okay, so that I can draw my asymptote. Okay, vertical asymptote here. And then draw your log. Well, as the base increases, that happens, right? It sort of looks like stretched out because it takes longer for the log to increase if your base gets bigger. What would you say for domain? X is greater than. You're just always missing one small thing, Elise. No. -4. X is greater than -4. It's to the right of -4, isn't it?
Yes.
Okay. Range is y equals all real numbers, and asymptote is x. I'm scared. X equals -4. Good thing I thought about that.
So why did it go?
That was so funny.
Because it's a log.
Oh, yeah.
Remember, a log is an inverse of an exponential function, and for inverses, to make them, you switch x and y. So if our old asymptote used to be y equals an exponential, when you switch x and y, now in a log it's x equals, which is vertical. It also has to do with like the reflection over the line y equals x, a horizontal line reflection becomes a horizontal line. What are you guys all laughing at? It made me super nervous. Oh gosh, okay. I'm like, do I have a big sign on my bum or something like that? Every time I turn around, there's giggles. It's making me nervous. Okay, any other questions? Okay, I'm going to stop there and give you your homework so you can get started.